lungs are where the body draws in vital oxygen and exchanges it for carbon dioxide. But every breath we take is accompanied by potentially harmful microbes, as well as particulates which can damage delicate lung tissue. To counter these threats, the lungs are enriched in immune cells that repulse invaders and repair injury. But this potent arsenal comes at a heavy cost. Overreactions or inappropriate responses result in diseases such as asthma. The lungs are spongy organs composed of increasingly finer tubules. First comes the trachea and the bronchi. These are then divided into the bronchioles, which are wrapped in a muscular sheath. At the ends of the bronchioles are microscopic air-filled sacs called alveoli. In the case of asthma, most of the harmful immunological events occur within the bronchi and bronchioles. The bronchial wall is made up of an epithelium covered in tiny hair-like structures called cilia, an interstitium, and muscle cells. Goblet cells scattered along the epithelium discharge a thin layer of mucus into the bronchiole lumen. The mucus is continually swept back up through the lungs by the action of the cilia. This system is known as the mucus escalator and is important for removing inhaled particles trapped within the mucus. Embedded throughout the bronchiole wall are immune cells such as dendritic cells, which sample antigens from the lumen, mast cells, which are packed with granules, tiny packages rich in histamine, and innate lymphoid cells, or ILCs. Individuals with asthma need to have been previously sensitized to a specific environmental antigen. The most common is found in the feces of house dust mites. But symptoms can also be worsened by respiratory virus infections, smoke, or pollutants. When inhaled antigens contact the epithelium, they trigger the release of two chemicals, IL-25 and TSLP, which stimulate nearby dendritic cells and innate lymphoid cells, those ILCs. The dendritic cells leave the epithelium for the lymph nodes, where they activate T cells and initiate an adaptive immune response. Antigen can also pass through the epithelium, especially in conjunction with damaging particles such as those found within tobacco smoke or diesel fumes. Some of this antigen can reach the mast cells housed in smooth muscle tissue. The mast cells of asthmatic individuals are unusual. They have more of an immune molecule called IgE stuck to their surface. The attached IgE then binds the relevant antigen, in this case from house dust mites, in a highly specific manner. When an antigen gets bound to two IgE molecules, it signals the mast cell to degranulate and spill out the contents of the granules. The granules' innards then exert their effects on surrounding cells and tissues. In asthma, the granule contents cause smooth muscle contraction and mucosal edema, leading to narrowing of the bronchioles. Many anti-allergy drugs target this key process of degranulation. Back to those T cells in the lymph nodes. Once activated, T cells enter the interstitium and team up with ILCs to escalate the asthmatic response. They secrete chemical signals that recruit other immune cells, most critical of these being eosinophils. These cells play central roles in almost all allergic diseases. Eosinophils squeeze through the epithelium into the lumen and begin releasing their own inflammatory signals, including IL-5, IL-13, and platelet activating factor. Together, these act on goblet cells, causing them to ramp up production of mucus in a process known as goblet hyperplasia. By now, the victim is in the midst of an asthma attack. As the attack proceeds, more and more eosinophils are recruited into the lumen and the mucus layer progressively thickens. The collective effects of smooth muscle contraction and mucus overproduction restrict airflow and result in the classic symptoms of asthma, including difficulty breathing, coughing, and wheezing. Multiple attacks can, over time, lead to fibrosis and permanent injury of the lung.